Hey everyone, Cam and Gideon here.
Starting? What?
Tina, we're recording. It's chapter 13, comparing two population parameters. In this unit, we will be going over two sample z-test, two sample z-interval, two sample t-test, two sample t-interval, two prop z-test, and two prop z-interval. Here we have the two samples z-test. The sample z statistic is x bar 1 minus x bar 2 in parentheses minus, in parentheses, mu 1 minus mu 2, all over the square root of the standard deviation squared over n1 plus the standard deviation squared over n2. When is this used? The two sample z-test is when two samples are given, obviously, and when the standard deviation of the population is known. If the standard deviation of the population is unknown, you would have to use a two-sample t-test. And the two-sample z-test infers out the difference of population using the differences of samples. To use, you need to follow three conditions. The data must be randomly selected, the data must be independent or practically independent, and the normality of the combined sample size must be at least 15 to use the central limit theorem. The null hypothesis for the two-sample t-test is that the mean of a population equals the mean of another population. This is a portion of a table that can be found in the pink packet and gives the format for the test statistic and its standard deviation for all two-sample tests. If you can remember the patterns of the two-sample tests and also the format of them, you can pretty much use this information to fill in the gaps for all of the test statistics of the two-sample tests. Make sure to look for it in your pink packet. Here we have the two-sample z-interval. When you look at the intervals, you can see that it has the x bar 1 minus x bar 2 plus or minus z star times the square root of standard deviation of 1 squared over n1 plus standard deviation of 2 squared over n2. You would use this when you have two samples, when standard deviation is known, and to infer about the difference of populations using the difference of the samples. It's basically the same thing as the two-sample z-test, except it's not a test, it's an interval. So that being said, all assumptions apply from the two-sample z-test to this two-sample z-interval. Oftentimes, you will know to use the two-sample z-interval because the question will ask for a confidence level. You cannot do a two-sample z-test with a confidence level. This is the two-sample t-interval. It is essentially the two-sample z-interval, but the standard deviation of the population is unknown. So the sample standard deviation is used in place, S. To use the two-sample t-interval, you need to have the same assumptions, except that to conclude normality, you need to have the sample size, combined sample size be at least 30 to use the CLT. Also, you need to remember that the t-distribution needs degrees of freedom for which the calculator output, or the smaller sample size minus 1, is used. Either works. The calculator output is better, but the conservative approach uses the smaller sample size minus 1.
But you always want a bigger sample size, right?
Yep, bigger sample size is better. Thank you, Mrs. Berry. This is the two-sample t-test. Just like its friend, the two-sample z-test, you use it when you're given an alpha level instead of a confidence level. Basically, same use as the t-interval, and the same assumptions apply. In the upper left corner, you'll have the test statistic, which is very informative. This is where things get difficult. The 2 prop z interval. It does not look like its friends, the 2 sample z or t interval. So make sure to pay extra attention to the equation because it's a big one. You'll use it when 2 proportions are given and to infer out the difference of population proportions using the difference of the samples. Data must be from a random sample, samples must be independent, and the normality of each sample must have 5 successes and 5 failures. Here we have the 2 proportion z-test. Again, with proportions, things look a lot different than samples, so you should make sure to pay extra attention to the test statistic featured in the upper left corner of this slide. Use it when 2 proportions are given, just like in the interval, and infer about the difference of population proportions using differences of the samples. The data must be from a random sample, the samples must be independent or practically independent, and the normality of each sample must have at least 5 successes and 5 failures. The null hypothesis is that the proportion of one is equal to the proportion of another, and the combined p hat sub c is used to replace the samples p hat sub s in all relevant calculations. The equation for p hat sub c can be found on the bottom right corner of the slide. We know you're probably not going to be studying for this test, but in the case that you are, which is very minimal, we've recommended some book problems here. If you do just these 4, we're sure you'll get at least a 1 on the test.